Can digital watermarking protect us from generative AI? We'll talk about it in a few moments, but before we get into it, U.S. Senators John Kennedy and Jeff Merkley introduced a bipartisan bill Wednesday to end involuntary facial recognition screening at airports. The Traveler Privacy Protection Act would block the Transportation Security Administration, TSA, from continuing or expanding its facial recognition tech program. It would also require the government agency to explicitly receive congressional permission to renew it, and it would have to dispose of all biometric data within 3 months. Senator Merkley described the TSA's biometric collection practices as the first steps toward an Orwellian nightmare. The TSA program is a precursor to a full-blown national surveillance state, Merkley wrote in a news release. Nothing could be more damaging to our national values of privacy and freedom. No government should be trusted with this power. The TSA began testing facial recognition at Los Angeles International Airport, LAX, in 2018. The agency's pitch to travelers framed it as an exciting new high-tech feature, promising a biometrically enabled curb-to-gate passenger experience. The TSA said this summer it planned to expand the program to over 430 U.S. airports within the next few years. For the latest on this story and more, visit Engadget.com. The Biden White House recently enacted its latest executive order designed to establish a guiding framework for generative artificial intelligence development, including content authentication and using digital watermarks to indicate when digital assets made by the federal government are computer-generated. Here's how it and similar copy protection technologies might help content creators more securely authenticate their online works in an age of generative AI misinformation. Analog watermarking techniques were first developed in Italy in 1282. Paper makers would implant thin wires into the paper mold, which would create almost imperceptibly thinner areas of the sheet, which would become apparent when held up to a light. Not only were analog watermarks used to authenticate where and how a company's products were produced, the marks could also be leveraged to pass concealed encoded messages. By the 18th century, the technology had spread to government use as a means to prevent currency counterfeiting. Color watermark techniques, which sandwich dyed materials between layers of paper, were developed around the same period. Though the term digital watermarking wasn't coined until 1992, the technology behind it was first patented by the Muzak Corporation in 1954. The system they built, and which they used until the company was sold in the 1980s, would identify music owned by Muzak using a notch filter to block the audio signal at 1 kilohertz in specific bursts, like Morse code, to store identification information. Advertisement monitoring and audience measurement firms like the Nielsen Company have long used watermarking techniques to tag the audio tracks of television shows to track and understand what American households are watching. These steganographic methods have even made their way into the modern Blu-ray standard, the Cinevia system, as well as in government applications like authenticating driver's licenses, national currencies, and other sensitive documents. The Digimarc Corporation, for example, has developed a watermark for packaging that prints a product's barcode nearly invisibly all over the box, allowing any digital scanner in line of sight to read it. It's also been used in applications ranging from brand anti-counterfeiting to enhanced material recycling efficiencies. Modern digital watermarking operates on the same principles, imperceptibly embedding added information onto a piece of content, be it image, video, or audio, using special encoding software. These watermarks are easily read by machines, but are largely invisible to human users. The practice differs from existing cryptographic protections like product keys or software protection dongles in that watermarks don't actively prevent the unauthorized alteration or duplication of a piece of content, but rather provide a record of where the content originated or who the copyright holder is. With the wheels of government turning so slowly, industry alternatives are proving necessary. Microsoft, the New York Times, CBC/Radio Canada, and the BBC began Project Origin in 2019 to protect the integrity of content, regardless of the platform on which it's consumed. At the same time, Adobe and its partners launched the Content Authenticity Initiative, approaching the issue from the creator's perspective. Eventually, CAI and Project Origin combined their efforts to create the Coalition for Content content provenance and authenticity. From this coalition of coalitions came content credentials, which Adobe announced at its Max event in 2021. Some security researchers have had enough waiting around for laws to be written or industry standards to take root and have instead taken copy protection into their own hands. Teams from the University of Chicago's SAND lab, for example, have developed a pair of downright nasty copy protection systems for use specifically against generative AIs. Dr. Ben Zhao, Neubauer Professor of Computer Science at University of Chicago, and his team have developed Glaze, a system for creators that disrupts a generative AI style of mimicry by exploiting the concept of adversarial examples. It can change the pixels in a given artwork in a way that is undetectable by the human eye, but which appear radically different to a machine vision system. When a generative AI system is trained on these glazed images, it becomes unable to exactly replicate the intended style of art. Cubism becomes cartoony. Abstract styles are transformed into anime. This could prove a boon to well-known and often imitated artists, especially in keeping their branded artistic styles commercially safe. While Glaze focuses on preventative actions to deflect the efforts of illicit data scrapers, SandLab's newest tool is wholeheartedly punitive. Dubbed Nightshade, the system will subtly change the pixels in a given image, but instead of confusing the models it's trained with, like Glaze does, the poisoned image will corrupt the training database it's ingested into wholesale, forcing developers to go back through and manually remove each damaging image to resolve the issue. Otherwise, the system will simply retrain on the bad data and suffer the same issues again. The tool is meant as a last resort for content creators, but cannot be used as a vector of attack. This is the equivalent of putting hot sauce in your lunch because someone keeps stealing it out of the fridge, Zhao argued. Thanks for listening to the show. Make sure to rate, review, and subscribe on Apple Podcasts. Today's show featured journalism by Engadget contributors Will Shanklin and Andrew Tarantola and was produced by Spoken Layer. I'm Imran Sheikh, and we'll talk more tomorrow.
Spoken Layer.